Mackie channel strips are the only ones of the Mackie plugins to have a slightly different feature set depending whether you load the mono or the stereo versions. Both plugs combine several different processes into a single interface, and some of these will be familiar to us already. The compressor section works in almost exactly the same way as the standard Mackie compressors, while the EQ section is essentially a 4-band version of the 6-band EQ plugs. They also offer a fully featured noise gate and filtering options, and the order in which these processes are connected is shown in the block diagram in the top right corner of the interface. In the mono version, the first block in this diagram is labelled F for filter. You can adjust the filter frequency using the knob or by dragging the point on the graph, and if you turn off the filter with the active button, the block will be greyed out to show it is inactive. If we ignore the KF block for now, the next one is labelled G for gate. Noise gates are similar to compressors in the sense that they are just automatic gain controllers. But unlike a compressor, a gate will reduce the gain level by a fixed amount whenever the signal drops below the threshold, in order to remove background noise or spill from other instruments, or to control the decay of the sound. Although the gate is active by default, the range control defaults to 0 dB. This means that no gain reduction will be applied at all, no matter what the input level, in much the same way as a compressor set with a ratio of 1:1. To set up some gain reduction, first drag the threshold node horizontally, then drag the range node vertically to define how much gain reduction is applied when the signal drops below the threshold. Often, a range of 20 dB or less will be enough to drop the noise or spill to an acceptable level, and this will usually sound more natural than the full 60 dB of gain reduction available. If you are gating a drum sound, you will probably need the attack time set to its minimum to avoid losing the transient at the start of each hit. But sounds that naturally have a slow attack may need a longer setting to avoid audible clicks as the gate opens. The release and hold times can be set to make sure that the gate stays open for long enough to allow a natural sounding decay on each note, or they can be used more creatively to shape the way the sound decays. The key in switch in the bottom right of this section will switch the high pass filter into the side chain of the gate. This means the filter will no longer have any direct effect on the audio signal, but will instead prevent the noise gate from responding to signals below the cutoff frequency. For example, to make sure that the gate on the snare drum mic only opens when the snare drum is hit and ignores the bass drum. The block diagram in the top corner now shows the filter section as inactive, and instead the KF key filter block is active and is feeding a parallel signal path into the side chain of the noise gate. You can monitor the output of the key filter by pressing the key listen button. This allows you to listen to the same signal that the gate is listening to while adjusting the filter. The compressor also has a key in-out switch, which is the only feature that doesn't also appear in the standard compressor plugs. This can be used to switch the high-pass filter into the compressor's side chain, just like with the noise gate, and this can help to prevent the compressor pumping audibly in response to loud bass signals. The makeup gain for the compressor is located under the attack time instead of being a fader as in the standalone compressor. You can use the output level fader instead if you prefer, but the compressor's makeup gain will be bypassed along with the compression if you switch the process off, which makes it easier to judge your settings. The key filter can be routed to the noise gate and compressor side chains simultaneously if needed, but if you want the filter back in the audio path, you must first turn off the key filter options in both sections. The EQ can be adjusted just like the full 6-band version, either by dragging nodes on the graph or by dragging over the parameter values themselves. and bands 1 and 4 can be switched to peaking mode rather than the default shelving type. It is also possible to change the order of the compressor and EQ sections. By default, the EQ is placed before the compressor, but this can be reversed with the DSP order switch in the top left corner. The order these processes come in is important, but there is no right or wrong way. If the EQ comes before the compressor, then changes to the EQ will also change the compressor's behavior, but whether or not this is desirable depends on the signal you are processing. As a general rule of thumb, I will put the EQ first if I am using it to correct problems with the recording, but put it second if I am using the EQ to shape the sound to fit into a mix. However, if it sounds better the other way around, I will always go with that instead. The bottom left corner of the interface contains a mute button and also a polarity reverse, which is exactly the same as the phase invert button commonly found on mixers. The input level fader above comes before all the processes and can be used to trim the input level if needed. Although this channel strip only has a mono input, it has a stereo pair of outputs, so the signal can be panned with the knob under the output level fader. The stereo version of the channel strip is mostly the same, but as it has stereo inputs instead of mono, the pan control is replaced with a balance control, and the polarity reverse button is replaced with individual phase invert buttons for each channel. Where the mono version has a single high-pass filter for either the signal path or the sidechains, the stereo version has a dedicated sidechain filter with extra options for low-pass or bandpass filtering, and also another signal path filter to its right. This allows different filtering for the sidechain and the main signal path if needed.